Hi there everyone. Right, today's lesson is on about lengths of lines. Right, now this is not just about kind of grab a ruler out and kind of measure it. Not really what they're after, and chances are that certainly in a higher GCSE paper they're not going to ask you to do that anyway. Maybe in a foundation paper, but certainly not in a higher paper. They're going to give you a bit of information and they're going to ask you to work out the length of a line. So we're going to look at how to work out the length of a line, probably from between two coordinates, or maybe something that's kind of drawn. All right, well, let's have a look anyway in terms of where I'm going with it so you'll understand. So to find the length of a line, you need to find the change in the x values and the change in the y values, and using Pythagoras. All right, so you can probably see straight away where I'm going with this one. All right, so this is about you understanding that Pythagoras is a technique, and please look at my other videos on Pythagoras. Is a technique to work out a distance. But when we're talking about a distance of a line on a coordinate grid, if we can have two coordinates there, then Pythagoras is going to support us because it's going to be able to create a triangle. All right, so let's have a look in terms of what I'm talking about. Now, don't worry too much about this notation in terms of what this looks like, because I'm going to go through that in a second. But ultimately, Pythagoras is normally a squared equals b squared plus c squared. So if I'm going to rearrange that a little bit, it's going to be a is equal to the square root of b squared plus c squared, where these two values here, this x2 and x1 here, these two here, and these two here, are going to be the values of the x coordinates, so the distance along the x-axis, and this is going to be the distance along the y-axis, so that's going to form the triangle. All right, well, let's have a look at that so you can see it. It's probably easier to see. Okay, so there we've got a line, a length of a line. It's not perfectly drawn, to be honest. Someone should have done a better job, but hopefully you can see it's going to go from there to there. All right, so we'll call it an estimate of the length of a line. All right, so in terms of obviously a ruler, and then I suppose you could look at that and try to measure it and assume that that's perfectly a centimetre, but that's really not what they want you to do. They want to use the grid accurately to determine how much it goes across and how much it goes up. All right, and that's going to be your distance in your x direction and distance in your y direction. All right. So this formula here is about using coordinates. All right, so I'm going to kind of try and tie them in together as we go. But if I say it now, you can see here it's 1, 2, 3, 4 along, and it's 3 up. Okay, so just try and remember that when we come to it: 4 along and 3 up. Okay, here we go. I'll write down change in x equals 4 and change in y 3. So you don't need to remember it. All right, so there it is. So the length is the square root of 4 squared plus 3 squared square rooted. All right, so this idea here isn't applying this rule just yet. It's just using the fact we've measured it along there and we've measured it on there in terms of x and y. So 4 squared is 16, 3 squared is 9, so 16 plus 9 is 25, and the square root of 25 is, of course, 5. All right, so that's going to be the length of that line. All right. Right, the other way of looking at it, and this is the other kind of concept, is that if you've got two coordinates given, so the two coordinates, so if I was going to take this one, that would be a coordinate there and a coordinate there, and you're not given this, all right, so you're not kind of shown that, and then we have to use this formula, and that's where this formula kind of comes into play, is we're going to use the difference between the x's and the difference between the y's, all right, because that's going to give me the difference in the x and the difference in the y's. Now, if I just come back to a second and I look at this one here, well, that one there from the x value was 1. So if I look at this one here, and that one there is 5, all right, so the difference in the x's is 4, isn't it? Okay, so that's where the 4 came in. Obviously, we just measured it. If I look at the difference in the y values, well, I've got this value here, which is 2, and it goes up to 5, so that's 3. So that's where these two numbers came from. All right, so we don't have it drawn for us, which we don't here, then that's what we're going to have to do. And again, it doesn't matter because we're going to add them. It doesn't matter which order we do it in, as long as we find the difference in the x's, square them, and the difference in the y, square them. Okay, so the length, here we go, is going to look like this. All right, and so it's going to be this horrendous little thing. But let me just kind of clarify. So what's the difference in the x's? 4 take away 2. All right, so 4 take away 2. That's the difference in the x's. That's this little bit. All right, so it's got a difference in the x directions of 2. That's what that is. The difference in the y's, 10 take away 7, is 3. All right, so 3. So what I've got is 2 squared and 3 squared. There you go. All right, so written it down. So this looks really, really complicated in terms of what they've done. And this formula looks really, really complicated, but just obviously try not to get bogged down in it. Again, we're looking for the difference in the y's squared and the difference in the x's squared. And that's all that is. And we're going to add them. And then, of course, using Pythagoras, we square root it to give us the length. All right, so 2 squared plus 3 squared. Well, 2 squared is 4, 3 squared is 9, so it's going to give a square root of 13. And it's not asked me to leave it as a decimal or to leave it as a third or anything like that. So if it asked me to leave it in third form, I'd leave it like that. And if not, and it asked me to leave it decimal places, then of course I would leave it to a relevant number of decimal places that the question asked me to do it in. Now, I didn't say from the outset, no one asked me at the outset, so I'm not really sure. But of course, in the exam, that's what you've got to be thinking about, is once you've done the calculation, what did the question say? Did it ask me for decimal places? Did it ask me for third form or not? Okay, so that's what you would have to do and check at the end. And I would guess that this root 13 would be a non-calculator paper, and the 3.61 would be a calculator paper. It kind of makes sense, all right. So that's how we work out length of a line. It's about using Pythagoras and using the idea of thinking the changes in the y's and the changes in the x's, and that's going to form this triangle. Okay, all right. Well, if you want some practice on it, please, again, if you want to revisit, please go to maths-school.co.uk. There are some questions on there for you to kind of practice, and hopefully you'll smash it later. All right, well, thanks for listening.